Let me start this section by saying that average is a leveling process. What do I mean by this? Uh, Let me just give you three numbers: 2, 3, 4. What is the average of this? The average is, sum is 9, there are three numbers, 9 by 3, so that means your average is 3. Now, a good way of demonstrating this visually is to have my numbers represented with blocks. That's my 2, that's my 3, and that's my 4. Averaging is just the process of making each stack of the same height. I have moved the one there. Now each stack has a height of 3, and that 3, so in this axis 0, 1, 2, 3. 3 is the average. It is just leveling of the three sets of blocks that I had. That is the fundamental thing you have to understand about average before we go further into the section. Also notice that if you take the number of observations on this axis and the size of the observations on this axis, what you have is a rectangle with a length equal to the number of observations and a height equal to the average basically, and the area represents the sum, which is the product of the average and the number of terms. So the area of a block can be used to signify the sum for a certain number of terms. Let's look at a very simple and direct question. The average of 47 numbers is 57, and it rises by 1 when a 40th number is added. Find this 40th number. The traditional approach to doing this would be to say that the old sum would be 47 into 57, which is how much? 47 into 57 is 2679. While the new sum, I have 48 numbers, the average is risen by 1, so it's now 58. What is that product? It is 48 into 58, which is 2784. 2784. The increase in the sum is on account of the last number that's added. So if you subtract these two sums, you will get 105, which is the 48th observation, x48. This would be the easiest way of doing it in terms of being very easy to explain, but it requires some unnecessary big calculations. These are not multiplications we need to do to solve this question. There are a couple of other ways of showing you how it's done. One is to simply say that my observation is, I'm going to do the same formula, but I'm going to do some algebraic tweaking. X48 is basically 48 into 58 minus 47 into 57. But can I not write this as 47 plus 1 into 57 plus 1 minus 47 into 57? When you open up this bracket, you will get 47 into 57 plus 47 into 1 plus 1 into 57 plus 1 into 1 minus 47 into 57. You'll notice that these two things will cut. So that takes away the burden of calculation to a large extent. You are only left with 47 plus 57 plus 1, which is 105. So just a little bit of algebraic tweaking to reduce the burden of calculation, but the same thing can be shown visually. I mentioned that if you can use a rectangle with length and breadth standing for n and a, so that the average would be your sum. So if I have n is equal to 47 and a is equal to 57, this rectangle's area represents the sum before the new number is added. And what happens after? You have a rectangle with n is equal to 48 and a is equal to 58. That's your new sum, and the increase in the sum was on account of adding the new 48th number. And the magnitude of this 40th number can be calculated simply by finding the area of this shaded section, which you can further break down into this piece, which is 47 into 1, this piece which is 1 into 1, and this piece which is 1 into 57. The exact same thing that we have done here, but done visually. And so the 40th observation is simply 47 plus 57 plus 1 is equal to 105. It reduces the burden of the calculation, and if you are very fluent with this approach, it actually saves time as opposed even to putting this on a calculator. And there are certain situations where you don't want to work with the sum. You want to apply a shortcut based on this idea. And we'll further elaborate on this. This was just an example to demonstrate what you can do with the visual interpretation, but this is not exactly how we're going to go about applying this concept. Let's see that next.